Hello. Good afternoon, Poland. Come on, a little more excitement. So, in Poland, do we start on time or do we give people a few minutes? Start on time. Okay, I like that. So, hello. My name is Miško Hevery. I am the creator of Angular and Angular 2. And I'm here to talk to you about Angular. And I know this is a Java conference, and you should know that deep down, Devoxx has a special place in our hearts for two reasons. First of all, I'm an ex-Java developer. And second, I feel like Angular really became popular after we presented it in the original Devoxx about 5 years ago. So it's kind of nice to be back. It wasn't in Poland. It was in Belgium. But nevertheless, Devoxx is special for us. So today I want to talk to you about Angular 2 and the differences in how we are come since original Angular. So first I want to talk about community. I think community is an important part of any framework or any project that you work on. And specifically, we're very proud of our community. So Angular 1 in October 2015, which was about 9 months ago, we had about 1.1 million 30-day actives. So these are people reading our documentation and browsing through how to use Angular. So presumably, you wouldn't be browsing the API docs unless you're actually using it. So we consider this a pretty good proxy. And we're proud to say that the community is growing. So as you can see, May, which was about a month ago, we have grown to 1.3 million active users. But what's more importantly, Angular 2, while still not in final, has already grown to 360,000 users. So together, we have in excess of 1.6 million 30-day actives. And we're very proud of that. But it's not just the community that's important, but also how people contribute. Now, we announced that we were going to redo Angular for Angular 2. And the original motivation is really wanted to get the speed up. We wanted to get the benchmarks up. And we wanted to embrace the future, which meant ES6, module loading, and really make it a faster framework. It turns out that we have grown in scope since then a little bit. And we really turned Angular from just a framework to a whole platform. So let me show you all the pieces in there. First of all, there's dependency injection, and I know for some of you guys who are coming from Java world, dependency injection is the bread and butter, and so you know how wonderful it is, but we're proud to say that we are the only JavaScript framework that have it as of right now, and we're very proud of that. I think it's a very cool thing, enables testing, enables many magical things. We've done the way we do decorators, and most importantly, we have something called zones, and zones allows us to propagate context across asynchronous operations. As you know, in JavaScript, there's only a single thread, and everything is scheduled on a timer or some other event in the future. And it's important to know which of these timers were originally triggered by your framework and which were triggered by application or some external thing, so that we can keep track of when is it time to do change detection. So zones really simplifies this. And for those who have done Angular 1, you know that a lot of times you had to do scope.$digest or $apply. This thing, thanks to zones, is a thing of the past. We've redone our compiler, and we're going to spend a few more minutes talking about it in a bit. The change detection was redone mainly to be faster on two levels. One is we wanted to generate faster code, and two, we wanted to make sure that we can do change detection in a single pass, so we instituted the data flow from top to bottom, which allows us to actually prune the branches and is very compatible with Flux-style programming and reactive-style programming. So if you like that kind of a thing, you can do that with Angular just as well as you can use the old classical way as well. And finally, we have these renderers that allow us to render not just to DOM, but to other things, which allows you to run Angular on a server, as well as on cross-web workers or native platforms, and we'll talk about that in a second as well. Now, Angular now comes with a set of widgets, which we call material design. This is the Google standard UI paradigm that we have. But we also have a lot of other third-party libraries. So there's Ionic, there's Widgimo, the Unseen UI, and many others are adding constantly to it. So when you're starting with Angular, it's good to know that there's lots of widgets libraries available for you to choose from. And so you can concentrate on building the application rather than the look and feel of the app. We focus heavily on mobile, and we'll talk about that later, and universal, which is our way of pre-rendering the code on a server for both faster experience, both mobile and desktop, and also an improvement experience for search engine optimization. We have a command line tool, which we'll talk about in a bit, which allows you to really take you through the experience of having absolutely nothing, an empty Git repo, all the way through deploying your application. So not just a framework for building the app, but also a hand-holding along the way as to best lay out your directories, your structures, your tests, your deployment strategy. Language services allows us to integrate with any existing IDE so that you can hit Control Spacebar in the IDE, just write a little tiny hook for that IDE that calls into the language services, which is a separate process, and it can answer questions about what is the possible completions at this particular location. Again, we think this is pretty cool, and this is something that I don't believe other frameworks have in JavaScript world. Finally, we have Augury, which is a tool, extension tool for Chrome, where you can debug. We'll talk about that more in a bit. ng upgrade allows you to take Angular 1 code and Angular 2 code and run it concurrently together, and you can mix and match individual services and components between it. So there's a clear migration path from Angular 1 to Angular 2. And finally, we have router, animations, and internationalizations. And so, as you can see, we really thought about the whole thing, how you take a project from the very beginning all the way to the very end, and all the things in between that you might need. And I think this is kind of the main differentiator, and why I think that this is no longer a framework, but it's really a whole platform for helping you build your applications. So proud to know that we are in Angular 2 RC. We believe we just released release candidate 3, or is about to get released. And we are heading fast towards final, which should come soon. And our philosophy is really to focus on performance, productivity, and versatility, right? So performance is, how do I make my apps to be amazingly fast for the user experience? Productivity is, how do I make my developers amazingly fast in building features instead of being, somewhere in the weeds? And versatility is, how can I make sure that I can leverage the knowledge I have and use it on different platforms in different ways? And so we'll show you that in a second. So performance, we really wanted to be small and fast in all scenarios. And that required a lot of rethink about the way we do things and the way most frameworks actually approach this particular thing. And so I'll show you how we started it. So we took all of our learnings from Angular 2 and we applied it to building, with all the learnings from AngularJS, and we applied it towards Angular 2. And we were able to get our rendering speed to be about 2.5 times faster, which is a great first step. But the re-render speed really shined at about 4.2. But it turns out that while that's fast, we had an internal customer at Google, which was AdWords, and they said, we want to go even faster. So they really pushed us to the limit, and we really rethought the way the whole rendering should happen. We made it about 5 times faster all through in all cases. And basically what it comes down to is we've taken the approach of code generation, and there's a couple of benefits for that. So let's go over how it kind of worked in the past. We had a HTML, which kind of got parsed by the browser, and got executed in the browser immediately. And so this is how AngularJS 1 worked. What we have done with Angular 2 is we added actually an optimization step in between where the compiler actually produces an internal AST, and then we can run optimizers for it where we realize that something can only be done once, or this particular case, these two cases always happen together, and we can inline them, and so on and so forth. Kind of like a real compiler. And then we can actually turn that AST into real either JavaScript code or TypeScript or even a myriad of other languages in the future, like, for example, even Java. And what this allows us to do is that allows us to then have a code base that can run in other places. So to kind of give you a point, the whole Angular 2 is about 170 kilobytes, and most of it is actually the parsers and the lexers and the compiler that actually build the application. Angular 1 in comparison was 56K, but because we can actually move all of these compiling stages into the build step rather than shipping it to the browser, the Hello World app is currently on 22K, and we are working hard to actually decrease it even further. And the basic philosophy is that the code we generate simply doesn't require the framework. So our goal is that when we take your application and spit out all the code, it is framework free. It is just the application tailored for what you need. And it has a couple of advantages. First of all, in Angular 1, what we did is we took the HTML and we fetched it using XHR. And then the browser actually parsed the HTML and produced a DOM. We then walked the DOM and built up internal data structures, and from those data structures, we actually ran the framework. And so it turns out that the framework could have never actually seen the user code that you write, right? Because the framework was written first. And as a result, a lot of code inside of Angular 1 is kind of this meta code of like, oh, eventually there will be code in here and I will have to invoke some function. But the side effect of the meta code is that it generates something called polymorphic code. And polymorphic code is really a fancy word of saying that the browser VM cannot figure out where this particular method will call next time it's going to be here, right? So every time it gets to this particular location inside of the code, the function call takes it somewhere else, and as a result, there is no optimizations that the VM can do. So contrast that with Angular 2, where what we've done is actually we take all this stuff and pushed it to a compile step, so it never actually gets to the browser. It's done as a build step. And we generate a source code, and the source code we generate is actually monomorphic. What that means is that as the application runs, the VM notices that every time it gets to this particular location, the call is always the same exact thing. And as a result, it can inline either the source code or it can create an inline cache. And there's a lot of benefits to be had. And as a result, the change detection inside of Angular 2 is about 10 times faster as it is inside of AngularJS. So couple that with this is just a raw speed improvement of how fast we can process it. You can couple that with additional features we have in Angular 2 where we can prune certain branches of change detection, or you can go even a step further and go into the push mode where you essentially are in the reactive where the only time the change detection runs is if there's a specific thing that has changed. And so by giving you this flexibility, you can really build large-scale applications. And so we have that at Google. So the new ads, the backend which allows the advertisers to bid for different ads messages, that is being rewritten in Angular 2. And this is a huge undertaking. It's a huge product, and it's a lot of developers. And so as I said, these are the guys that have pushed us to build something that is so scalable. So then what we do is we take the offline compile, we inline the modules, tree shake them, and minify them. So let's look at it a little more closely. So what inlining really means, offline compilation really means is that instead of running the code through a generic framework, kind of an engine that is, as I said, polymorphic, imagine you have this simple template, hello name. What happens is we generate this kind of for each component, we generate this kind of a class for you, which in the constructor instantiates the components, and it turns out that this is the most efficient way to actually build DOM. I know in the past, people always said that inner HTML seems to be the fastest. The browsers have evolved, and it turns out that the fastest way is to simply just instantiate them. The nice side effect of instantiating is that you get a direct reference to this particular element. So as you can see in the lower section where it says detect changes, we can directly call setText on a specific element with the new value. Now the other thing to notice is the way we simplify the change detection. Instead of running through some kind of a framework which kind of tries to figure out what's going on, we simply generate a code where it simply says, if this last name is not equal to name, right, which matches the name in here, we simply update the DOM element. So as you can see, there's very little you could do to actually make this faster because as we call this is obviously fast, right? Like if the value needs to be updated, go update it. There's nothing else in between that could be removed. Actually, it turns out there is. There is the renderer currently, which does a form of indirection so that we can render in multiple places. VMs do a very good job of inlining this particular code because this code is considered monomorphic. But it turns out that on startup, the VMs don't inline just yet because they don't know what needs to be inlined. So the startup has a little bit of penalty. And so to add to that, we're actually working on a new output for our compiler that is going to be specific to a specific renderer. So we can have a DOM-specific output. We can have a native script-specific output, React Native, and so on, maybe server-side specific output. And as a result, we will be able to even further increase the performance of the rendering. The other benefit you get out of this is that you get error messages that are easy to read. In the past, when you got a dereference error or some kind of a message, the stack trace was filled with all kinds of frames from the framework, which is kind of hard to understand unless you really understood the inner workings of what was going on inside of the framework. The new benefit here is that because the code is generated, you can go to the source code and you can see what's going on. You can see that we're comparing two values and we're trying to write, and you can see that there's a null pointer exception on this particular location because you didn't specify some data. And so as a result, we believe that it's actually going to be easier to debug and understand what's going on in your application. Okay, so the next thing you do is that JavaScript got ES6 modules, and they allow you to break up your application in lots and lots of small files using imports and exports. And this is the best practice. But it turns out that to actually assemble all the pieces together, there's a certain overhead. And the overhead is constant per file. So the right thing to do, which is to break up your application into lots of small files, is actually the wrong thing to do in terms of performance, because it means that the more files you have, the more time you pay this penalty of assembling them back together. And there's tools that do this, so for example, System.js, that bundle it up. But one tool in particular that does this is called Rollup. And what Rollup does is it essentially does a very smart concatenation of the files and gets rid of the import statements. Now, it's more complicated than just concatenation, because you have to make sure that you do it in the correct order. You have to make sure that the symbols don't collide. There's some renaming to be done. But fundamentally, it turns it into a single large file that doesn't have any imports or exports. And as a result, you get to save a lot of bytes and a lot of performance in terms of executing of this code. The next thing you do is we tree shake it. So we realize that because the code is generated, we actually don't have a dependency on ng compiler. And so as a result, we can drop it. Now, this slide is only showing it kind of on a high level, but we can go actually further. We can actually notice that you didn't use a specific directive or a specific component or specific feature of the framework, and we can tree shake that as well. So in the end, the only thing that's being shipped to the client are things that are actually being used by the application, which further reduces the size of the code that you ship. And finally, you run it through some kind of a minifier/munger that makes it small. And this is the pipeline that we're trying to automate using the CLI tool, so you don't have to think about it much. But this is the pipeline that results in some significant savings. So you can look at this as a number of requests for the applications, which is how many times the browser has to issue a request to render it. So you have the UMD, which is a style of setting up modules, or CommonJS bundled. You can see how it goes from 12 to 4. But it turns out that if you compile inline and tree shake, your whole application can be delivered in 2 requests. And this has impact on, for example, size. You can see how the size of the code that you actually have to ship to the browser decreases. And also load time. Because you're shipping less code, the browser has needs less time to parse it, analyze it. There's less requirements for memory. All of this bodes well for mobile devices as well. And so your final product really bootstraps amazingly fast. It is really noticeable where you navigate, you hit refresh the page, and it's almost instantaneously renders the output. I mean, 130 milliseconds is really a blink of an eye. So right now we're somewhere between 45 and 25K, depending on how you slice it. But our goal is to really push it further. And as I said, we're kind of just embarked on this particular journey of having a compiler and code generation and tree shaker. And so we're doing many things to improve this particular thing. And our goal is to be at 10 kilobytes for Hello World, maybe even smaller. At the beginning, it sounded pretty audacious that we can get 10 kilobytes. I'm now starting to actually feel optimistic that we can actually break that barrier and go even further. Anyways, our boss has promised us a cake, so I hope you agree and hold out for us. All right, the next thing we can do is lazy loading, right? Your applications are huge, and there's no need to load the whole of application into your code base, into the browser when you navigate to it, right? You only want to load the section of the code that you need. And so we can break up the application into individual parts, and then the router can be done in a way which only loads a particular part on as-needed basis. So if you only navigate to the main settings of the app, you get one route. If you go to the admin section, you may get a different chunk of code, and so on and so forth. Now, the next thing to make the experience even better for the user is to do a universal rendering. What that means is that you would really like to pre-render the code on the server. Now, in Angular, we did a lot of things to make this possible. Mainly, we worked really hard to make sure that there is no references in your code base to DOM at all. Because the moment you depend on DOM, you're pretty much saying you can only run inside of the browser. And so a lot of things in Angular 2 have been redone around this idea that you should be able to express yourself without having access to the DOM. The other thing that was important for us is that the way you express yourself inside of the Angular 2 is that the code you generate, the way you express yourself should be in a way that is tools friendly. all right, so that it's statically analyzable, so that tools without having to do too many complicated inferences can actually build up and process and do something useful with this thing. And so what this actually allows us to do is, for example, take the framework and run it on a server. So when a request comes in, we can execute it. We swap the renderer from the DOM renderer to a string renderer or something like that, and then we can generate a response to the browser in pure HTML and CSS. And this is important for mobile and even for desktop applications, right? Because if you can deliver HTML and CSS, the browser can render it. It can actually render it progressively as the HTML is coming on, provided that you have set it up correctly. And then after we ship HTML and CSS, we actually send the rest of the application over, and we do a little switcheroo in the application so that the user doesn't even notice, but all of a sudden they're on booted application. And that really helps with the time the first time that the user can look at the code. One of the things we do actually is we send the HTML with a little tiny JavaScript code, which actually records the user's interactions with the page, and then once the application bootstraps, it plays back those interactions. So if the user is super quick and clicks on a button, but the application isn't bootstrapped yet, once the bootstrapping happens, the click event is replayed to the application and can take it further from there. So this is a really nice experience. And as I said, it's also important for search engine optimization. This runs on Node.js because it's obviously JavaScript, ASP.NET, even on Java and JVMs through the help of the modern JavaScript interpreters in the VM. I believe it's called Rhino, right? The next thing we can do is web workers. So, I said earlier that we worked hard to make sure we're not dependent on DOM, but obviously Angular internally has to depend on DOM in order to render. So to bring the Angular to the other thread, the other thing to remember is that JavaScript is single-threaded, right? And as a result, many devices that you have, even in your pocket, your mobile phones, have multiple cores and could benefit from the advancements of having additional core, but how do you break up your application? So one of the things we can do is we can actually run your application inside of the web worker. In other words, if you build your application and you're disciplined, you follow the best practices, and you don't refer to any DOM inside of your code, then your app, along with the framework, can run inside of the web worker. And then we swap up the renderers so that we can render into a serialized mode where we can serialize the rendering instructions across the wire into the UI thread where all the rendering and animations can happen. So your UI thread is responsible for rendering, composing, paints, layout, also is responsible for animation and just creating a very nice rich experience, while your application thread can do the complicated stuff of fetching the data, processing it, creating filters, and so on. Okay, so let's talk about productivity. So far we talked about how you can make a really nice experience for the developers, for your users of the application. So let's talk about the developer, how you can have a fun time. So first we have Angular Augury. This was done by the community. This is actually not done directly by us. But so imagine you have an application. So for example, this is a kind of a kitchen sink of all the different components that you have. And inside of this application, you would like to know how it works, how it's hooked up. So what you can do is you can go inside of the Augury. Notice it's another tab inside of the Chrome DevTools. And there you can see your logical view of the application. You can see how the components are arranged in a tree-like structure, what properties they have, what are their inputs, outputs, what's their current state. You can interact with those components, and you can really find out what is going on. And so it's a kind of a great debugging tool, which is on a level of Angular components rather than on the low level of the individual source code lines and individual things. The other thing we can do is the tool can show you your routes, so you can kind of see the application overall. Where can you navigate, what the status of the navigation is, etc. And we can do the same exact thing for dependency injection, so that you can see why are you getting a particular component and where it's coming from. The other thing we worked hard is we wanted to simplify how Angular is built. And so in Angular 1, we had a huge number of directives, but 43 in particular of them, it turns out you don't need in Angular 2. Because all of those directives can be expressed simply using a square notation and parentheses. One means bind to a property, the other one means bind to an event. And not only it allows us to get rid of all these components, but more importantly, it creates a neutral language for binding to things. And because of the neutral language, we can bind not just to DOM, but we can bind to web components, or we can bind to native components, which we'll talk about in a second. And so it really simplifies the mental model. And this is just one example. The other places where we simplify things is we made things more declarative. We made things easier to understand, got rid of many concepts. So all in all, I think Angular 2 feels a lot more natural and, to developers than Angular 1 did. The thing is, it's one thing to build an application by yourself, but usually you have a whole team of people, right? And so one of the things we wanted to focus on is how do we make sure that you can have large sets of teams working on it? The first thing we do is we have a style guide. We basically say, we believe these are the best practices. We think you should follow them. So while in Angular 1, the style guide eventually happened many years after we initial release and was kind of driven by community, we really took it upon ourselves to make this from day one available for you. This basically lays out the best practices and make sure that everybody on your team is following the same style and practices. To that, somebody in the community actually built a Codalyzer, which is a tool which will verify that you're actually following the style guide. So instead of just relying on other humans to check you, you can actually have the boring job, hand it over to the computer, and make sure that your source code is always up to the style guide. Okay, we talked about the command line interface tool. The CLI tool allows you to make it super easy to get going with a brand new application. So you obviously install the CLI tool. You simply say ng new, my favorite amazing application. You cd into that directory and do ng serve, and you're ready to go. It's that simple. What the CLI tool will do is it will create the project, generate a basic set of components to get you started, set up the dev server, set up scaffolding for your test, make sure you have linting formatting, generates basic routes, sets up your test, pre-processing for CSS, and will immediately allow you to do a deployment build. So right from the get-go, you have all the pieces you need to kind of get started and get productive and simply focus on building your application rather than all of the bookkeeping that has to usually happen with a project. And as Angular CLI will evolve and add features, you'll get those benefits too as well. So what previously was a large number of configurations that had to happen is really boiled down to just a couple of simple commands to get you going. The other thing I don't have a slide here for, but I'd like to mention, is that we really think, while you don't have to use TypeScript, it is something that we think makes a huge difference. I don't think I have to, at a Java conference, be telling you the virtues of having type systems and the benefits you get out of them. But with TypeScript, it's really the best of both worlds. Turns out that all JavaScript is already valid TypeScript. And this is kind of the selling point of TypeScript, rather than they're not trying to reinvent the language. They're simply saying, look, JavaScript, what it is, we will accept it with its good parts and bad parts. What we're going to do is we're simply going to add a type system to it without having any sort of opinions how the language should be. And so what TypeScript is really just pure JavaScript with optional types. So because the types are optional, if you don't put any types anywhere, that's why JavaScript is a valid TypeScript. But even so, even if you don't have any types, the TypeScript's inference engine will allow you to infer many different types. And as you're building your application, even if you don't use types yourself, it will be useful when you call into Angular, or if you try to use some of the Angular APIs, the TypeScript IDEs will be able to provide completion and verification of that as well. So it's a good benefit. Okay, let's talk about versatility. So we want to make sure that when you learn this new skill of Angular, of building a web application, you can apply that skill not just for building websites, but also for building mobile websites and also desktop applications. So let's have a look what are the choices. So first we have Angular Mobile, and Angular Mobile is a set of features, styles, guides, etc., which allows you to build progressive web apps. Progressive web apps, the idea is that it's a website, you navigate to it, and there you have a link that says, oh, turn it into a desktop icon, not a desktop, a mobile icon, which will go into your kind of a desktop on mobile, right? And then you can, next time you visit, you just click on the icon. What the icon actually does is it sets up offline caching for both your application and your data. allows you to render quickly. And so you have kind of a native experience, but it's progressive in a sense that you start with a web page and it kind of slowly moves on rather than having to install it. So the user experience is serve to place, auto-install to the home screen. We support, as I mentioned, we support caching, push notifications, being offline, universal pre-rendering so that you can, when the user navigates somewhere, the thing we talked about earlier about having the server push the original page. You can do it in web workers and CLI. So again, everything you need to kind of follow the best practices for building mobile web applications. It's not that the other frameworks don't support this, it's that just we have done the time and effort of building all of it into kind of a seed which gets you started and figured out the best practices for it. Now, once you go mobile, you probably want to say, well, how do I, what kind of widget libraries do I use so that it kind of looks like a native application? So first choice you have is Ionic. Ionic basically is using HTML's divs and spans and lots of CSS to make it look like a native application. And Ionic does a very good job, so it can look either as an iOS or Android or Windows application. And you're building essentially in HTML your app that looks like a mobile app. Now we have another choice, and that is NativeScript. And the NativeScript is from a company called Telerik, which we work with. And what they've done is they created interfaces to native components. So they allow us from JavaScript to call, make a new button. And underneath it, instead of just creating a div, it bypasses the whole HTML, and instead it goes to a native API and says, okay, on Windows I have to call this API, on iOS I have to call this API, on Android I have to call this other API to get you a button. And as a result, what you're building is not a div that looks like a native component. You're actually building a native component, which is indistinguishable from the real thing, because it is the real thing. And the other choice you can do is you can actually use React Native. So React Native, just like NativeScript, takes the approach of making a bridge between the JavaScript world and the underlying platform API. The difference with the NativeScript and React is that React is a little more low level, so you can do more powerful things. But on the other hand, there's a different API for iOS, Android, and Windows. So with React Native, you're essentially building 3 apps, one for each mobile, but you're doing it in the comfort of JavaScript, TypeScript, and all the Angular 2 tooling that you provide. With NativeScript, you can actually build truly cross-platform applications across it. The other thing we can do is we can use Electron to build a desktop application. And in Electron world, basically what you get is you get a shell with a regular window that looks and feels like a native window. And inside of it, there is a Chrome for rendering and Node.js for reading and writing to the devices, such as reading into file system, I/O, etc. All those things that are not possible in a browser. But there's a problem. I mean, while you can do all these wonderful things, you can do menu notifications, HTML, JavaScript, CSS, the whole 9 yards that you're familiar with, all the technologies you're familiar with. It's kind of a pain because when you're inside of a Chrome and you want to access a file I/O, you can't just access a file I/O because Chrome doesn't allow that. So instead, you have to send essentially an HTTP request over to Node, and then Node on your behalf does the request. And so it's not a most ideal development model. But that looks awfully familiar to web workers. And so what we can actually do is we can actually move your application from the Chrome side into Node.js. And in Node.js, your application has full access to all of the wonderful API that Node provides. But it doesn't have access to the DOM. But that's OK, because we already know how to marshal all of your DOM rendering across the wire into the Chrome and render it. So you kind of get the best of both worlds. You get to run your application in a rich environment that has lots of native APIs, and you get all of the easiness of building UIs in HTML. So it's faster. As I said, we got platform APIs. Finally, let's talk about UI components. As I said, there is material design and lots of friends. And by this, I mean you can choose Ionic, NativeScript, Unseen UI, Widgemo, server faces, and many more, which are available to you to be used in Angular 2. So there's a pretty rich ecosystem to choose from. Finally, we have Rob, Stefan, and Jules. These are our new Angular advocacy group, which we have just started. And their job is to really just reach out to you guys and make sure that we hear you, we get back your feedback, we work on things that matter to you, and also to kind of spread the best practices and collect the best learnings from the community as well. So we're looking forward to getting all the feedback from you guys and can really incorporating into Angular. And of course, we're an open source project, and we are true open source in the sense that we actually develop on GitHub, and then we actually push to Google 3 internally, rather than kind of many companies kind of develop internally, and every once in a while they throw it over the fence. And as a result, because we're truly external, we have our issues on GitHub. You can see everything that's going on. You can influence any piece of it as well. You can also send us pull requests. And we do take pride in getting them in as much as we can. And we do take a lot of pride in our community, and I think a lot of people will tell you that Angular 2 Communities is one of its best assets. So this is our new Angular 2 website. You can notice that we're not even in final, and we already have lots of books to choose from. We have lots of training and courses available. We have a lot of toolings. You can have just about any major IDE. It works with Angular 2. And when I say works, they actually have specific feature that was added to Angular 2, so that when you're editing your template, it actually knows about the context of things and does auto-completion. You can do refactoring across templates and so on. And we think this is wonderful for a project that, as I said, we're still in RC. We're not quite final yet, but we're going to be there soon. But already you have all this great support. So let me show you a couple of examples of things that we have done with it so far. I already mentioned that internally at Google we use Angular on the new version of AdWords. There's also Google Fiber being written on top, is written and launched on top of it, and a few other projects. But externally, we worked with Kiva. Kiva, as you may know, they do micropayments and microlending. And so they built an application, a mobile application, for their needs. And this mobile application was built using Angular 2 and Ionic. And you can see it really feels like a native app on a mobile device, even though it's actually HTML and CSS. The learnings from it is, we got fast, make it look native. The key over there is that there's a really good dev cycle, right? So in a mobile development, usually you have to go through this recompilation and relaunching. Because this is all HTML and JavaScript, the refresh cycle, the wonderfulness of just hitting F5 to kind of refresh your application and go on are some of the benefits. And because it's Ionic, you are simultaneously developing for iOS and Android and Windows. Another example is NativeScript. So as we mentioned, NativeScript are truly native components. So here we are taking our renderer, and instead of rendering into the DOM, we are now rendering into this trampoline layer that actually calls native components and instantiates them. And NativeScript has a rich set of things. As you can see, they have charts, graphs, tables, etc. And so they launched, actually, they're so excited about Angular that the NativeScript 2.0 is actually based on Angular, and it's part of their offering. And so here's an example of what this looks like. You write code, which looks like a standard Angular 2 code, where you kind of describe, you have your annotation, you have HTML, CSS, and inside of the HTML, even though it's called HTML, it's really XML. Inside of the XML, instead of using divs and spans, you use whatever the equivalent is inside of the native, right? So you would say, choose a particular layout, you'd say create a button, put that button to the north side or something like of that sort. And because the components are stylable, so they have a style sheet you can attach to it that says, oh, on this component, make sure the font is red, and so on and so forth. So it's a very kind of a natural extension of how you are used to developing, but instead of developing for the DOM, you're actually developing for the native. So on the right-hand side, you see what that actually looks like. It looks native, and just for kind of kind of showing off what we can do. Notice every time you click, it kind of explodes a bunch of things, something that is not trivial to do in HTML, but it is trivial to do in native. One of the companies, for example, is Fidelity. They actually built, using all this stuff, an application for their customers where you can go and look at your account and do many things in there. And so that's NativeScript if you want to check that out. Another example I have for you is Lucid Charts. So this is one of the first applications built on the web, large-scale applications that allows you to build flowcharts, kind of omnigraphal of the web. And originally it was built using just pure JavaScript and Clojure, and it was redone inside of Angular 2 and TypeScript. And so the benefits of it is that they got about almost a half as many lines of code in Angular 2, and significantly fewer DOM elements. So it turns out if you do something in the framework, you can really be consistent about and efficient about how you do things. And so you can see about a third, 1/3 of the DOM elements as before. Another example of things we have done already is Capital One. And so Capital One actually used AngularJS, and the big problem they had is that when you navigate to an AngularJS application, when the search engine comes and crawls your application, and then you search for it, something like this shows up in the search result. And obviously, that's not what you want your customers to do. So in AngularJS, the Capital One had to build some kind of a system internally to be able to answer the SEO queries. But with Angular 2, it kind of comes mostly out of the box for this as well. So with the universal, what they were able to do is actually present to the crawler the actual rendered application, right? And so not only can they do that for the crawler, but notice that the time to paint has actually got shifted all the way to the top, where they were able to paint the code, paint the user interface much faster, and as a result, the user could interact with the system much, much faster as well. Anyways, so I wanted to show you both what we're doing, what the mental model is, how we're building it, and also show you that even though we're in not quite final yet, but we're in RC, already wonderful applications are being built with it by large teams that are building significant stuff. And so I'm super excited about it, and I welcome all of you guys to join us and build your dreams apps in here. Thank you. There is 7 minutes on the clock. I'm happy to do a Q&A. Or not. Oh, there's a question.
Hey, this guy comes here.
Okay.
It was pretty cool.
Thank you. Yes.
Okay, so the question is, Angular is just a framework, so as you said, in future it's possible to use Java or any language, and actually it's possible now, thanks to the community, there is something like Angular to boot. And my question is whether you see some real benefits of using Java instead of TypeScript or Dart, so stronger typing or something more maybe?
Okay, so the question was, is there benefit to using languages like Java in the framework? Because on the end of the day, your application has to run in the browser. Because on the end of the day, it has to run in the browser, and the browsers, as of right now, they only have JavaScript. You really are restricted to JavaScript or TypeScript. And I say or TypeScript because it's really important to understand that TypeScript is really just JavaScript with optional types. I mean, the difference between TypeScript and JavaScript can always be explained by you run a very fancy regex expression that strips out the types, and all of a sudden you have your JavaScript. If you choose languages like Java, you can then use something like GWT to translate from Java to JavaScript. But such translations are never perfect. And so you'll discover that there's a lot of nuances where things don't work. And then the second problem is when you are debugging your code base, you're looking at code that you haven't written. It's kind of hard to recognize, there's extra variables, there's extra stack frames. Source maps kind of help, but not really because it's just so fundamentally different. And so there should be a distinction made between languages that are essentially JavaScript and languages that are fundamentally different, and they have to do semantic matching. And while it is possible, it is something to keep in mind. Now, the benefit would be that we could take the templates, and because we have this whole compiling pipeline, we could very easily generate Java code on the output so that we can render in Java. And we are thinking about that. What's not clear to us, though, is then what do we do with the actual code, right? So you would have to write your controllers also in this particular format. And if you do, then we'll kind of work on a server as well, and it will be relatively straightforward to get there. So it is something we're exploring for it. The other way to think about it is you can just take the HTML template and you just write a completely different controller on a server, which is a reasonable thing to do, given that there's so many differences between how you fetch the data in a browser and the client. So that's another option we have. And so the choices we have is we could generate for different languages, or we could generate templates which are popular for those languages. So for example, when we're working with PHP, what we can do is we can take a HTML template that's in Angular 2 and convert it into a Twig template, which is very popular in PHP, right? I think I got this right, I'm not sure. And so we can do similar things for other templating systems as well. So this should be relatively straightforward to do.
Do you still support Dart development for Angular 2?
Yes, Dart is still supported.
Any more news about that?
And what?
Any more news about that?
Yes, there will be more releases.
Do those applications that you mentioned are built using the stack with Angular CLI in TypeScript, so it is purely usable?
Yes, most of the applications I mentioned are built using the full stack, yes.
So the Angular CI is working pretty nicely, and I don't have to, let's say, create my build script from scratch or using some third-party Yeoman generators?
It all works. The reason why we're not declaring final just yet is we have a little bit more work left on generating the, kind of putting all of it together. So currently, the offline compilation works, we generate files, but it's not as smooth as we would like. It requires a little bit of extended knowledge. And so we're putting a few more things in there to make it really smooth and transparent to the developers, where the online version, where the compilation happens in the browser, and the offline version are about the same complexity. It should really come soon.
You said you could use React for building those web apps, yeah? It was an alternative version.
What I meant was a reactive style coding, where you have subscriptions like RX Store or Flux. React as a framework is a rendering thing. So, I mean, they would kind of be arguing about who gets to have the DOM. Like, you can certainly embed a portion of React applications out of Angular 2 and vice versa. The point is that any single one DOM element needs to be owned by either Angular or React. But really what I was getting at is the reactive style programming. If that's what you like, we certainly support that.
Okay, but you said, do I need to build a whole app in Angular, or can I just build like one component with just something and embed it in the already built big React.js application? Or does it have to be a separate app?
So sorry, it's a little confusing. You can certainly mix and match reactive application with Angular application. But what I was referring to is the ability to follow the reactive style programming, where you have these events that flow to the store, and then the store produces a immutable copy and so on. So this particular style of programming allows the change detection to be a lot more efficient, because we can simply compare references and realize nothing has changed, and not even bother updating the whole particular branch of the change detection. So this is what I was kind of getting at. Having said that, you can also actually take a reactive application using reactive framework and embed it inside of the Angular. So that's also possible. And I think the time's up. We have 30 seconds. Well, thank you so much, guys. I really appreciate being here.